What's up everyone, welcome back. Patrick here. Moving on to the next video. We have to factor each of these expressions, and this is going to be a video where we're going to be dealing with special cases of difference of squares and perfect square trinomials, and also in the next video we'll be doing the same. And the same process is going to apply once we're factoring it, but notice that these are unique formats that we haven't run into yet, but you may run into them in your homework, on tests, or in your textbook. And so I just wanted to go over a few just so you're comfortable and you could see how we can apply the process for factoring for different kinds of expressions. So starting with part A, we got 16 a squared b squared minus 40 abcd plus 25 c squared d squared. So first thing you always check with factoring, can we take out a greatest common factor? And notice that between the 16, the 40, and then the 25, can't take anything out of that. And notice with the variables, there's an AB over here, an AB over here, but there's no AB over here. And then there's a CD, CD, but no CD variable in that first expression. So we can't take out any variables. So unfortunately, we can't take out any greatest common factors to simplify this expression. So let's see if we can maybe factor this with decomposition. Because if you notice the pattern here, we have a squared b squared, then we have c squared d squared, but then all four of those variables are in that middle term. And so we might be able to do something with decomposition. So notice that the a value is 16, the b value is negative 40, the c value is 25. What would the ac value be? 16 times 25, which would give us 400. So what two numbers multiply to 400 and add up to that b value of negative 40? That would be negative 20, negative 20. So notice that because these two numbers are the same, we're probably going to end up with a perfect square trinomial. And so if we decompose that middle value into those two values, so just be careful here with your variables, don't leave anything out. Right? So we decompose this middle term into these two terms, and we got the plus 25 c squared d squared. So now here what you want to do is factor by grouping. So between the 16 and the 20, notice we could take out a 4, and then there's an a squared and an a to the power 1, so we could definitely take out an a, and then notice b squared, and then we have a b to the power 1, so we could definitely take out a b. Right? The c and d is over here, but it's not over here, so we can't take that out. So what would we be left with in the brackets if we factor out a 4ab from these two? We would be left with 4ab, right? 16 divided by 4 is 4. A squared over a to the 1 is a to the 1. B squared over b to the 1 is b to the 1. Minus 20 divided by 4 would give us 5. Notice that the a's would cancel out, the b's would cancel out. We'd be left with cd, like that. Okay, from these two, what can we take out? There's a negative here, so we're definitely going to take out a negative value between 20 and 25. We could take out a 5. And then notice that we have AB over here, but we don't have an AB over here. So we can take out those variables, but we have a C to the 1, C to the 2, so we could take out a C. We have D to the 1, D to the 2, lowest exponent is D to the 1, so we could take that out as well. So what would we be left with if we take out a negative 5CD? I'm just writing this out over here just because we're dealing with a lot of variables. So you got to be really careful with your steps. Negative 20 divided by negative 5 would give us 4. Notice the c's cancel out, the d's cancel out, and we'd have AB. 25 divided by negative 5 is negative 5. Notice c to the 2 over c to the 1 gives us c. D to the 2 over d to the 1 gives us d, like that. Right? And then notice, as expected, that bracket is the same in both. We could take out that bracket, and what are we left with? 4ab minus 5cd. And so the final answer for part A ends up being that factor squared, like that. So we do indeed end up with a perfect square trinomial, right? So same process as before, it's just there's a lot more variables to deal with. So you got to be really careful with your steps, especially when you're doing the factoring by grouping. Now, another thing I want to mention, just in case your teacher is maybe expecting you to use that perfect square trinomial formula, if we have this, that's equal to a minus b squared. And we're dealing with the negative case, right? Because there's a negative over here. If your teacher is not using this formula or your textbook isn't, then you could just forget about this part. But if they are and they want you to rewrite in this formula like we did in previous videos, what you could do is this portion you could rewrite as 4ab squared. This would be 5cd squared. So notice that the a value is 4ab, right? A squared, 4ab squared. Then the b value is 5cd. And then over here we'd have minus 2 times the a value, which is 4ab, times the b value, which is 5cd, like that. So we'd end up with, when we multiply this out, notice that we do indeed get that middle term, right? And so it would factor, because it's in that format over here, right? Then we know it's a perfect square trinomial, so it's going to factor into that a, which is 4ab, minus 5cd squared, right, which is this over here. But again, if your teacher's not using this formula, you could just ignore that part and just do the decomposition. Whichever way you factor this, it is factoring into that. So just make sure whatever process you're using, you're getting that same value. Now, part B, we got 144 minus x plus 7 squared. So this is an interesting one. First thing we always check, can we take anything out? Notice we got the 144, and then there's like a 1 over here, so we can't take out any numbers initially. We can't take out any greatest common factors. Now, there's multiple ways to go about this. You can actually expand this if you want. Like you can expand the x plus 7 times x plus 7, FOIL that out, then distribute the negative in that bracket, and then factor from there. But I wouldn't recommend going that route, because if you notice, we actually have a difference of squares here, because I could take this 144, I could rewrite as 12 squared, and then this x plus 7 is already squared, right? So we're dealing with a difference of squares there. Remember, a difference of squares is that right there. And notice that this is in that format, right? So you got to be on the lookout for these kinds of expressions. These are actually going to be, the rest of them are going to all be difference of squares, because we have these 2's over here. But sometimes you'll just have a number, but lots of times that number you can rewrite like this. And so if we take this and apply it to this formula, notice that the a value is 12, right? We got a squared, 12 squared, minus b squared, x plus 7 squared, so the b value is x plus 7. So if we take these and plug them into the formula, we'd end up with 12 minus b, so be careful here, you got to put that whole b value in its own bracket. We're subtracting that entire b value, and then we'll have 12 plus x plus 7. Because there's like a 1 over here, we don't actually have to write the brackets, but I'll write them just so you could see clearly. A minus b, a plus b, right there. And then you have to simplify the brackets, so you'd end up with, when we distribute that negative, we'll have what, 12 minus x minus 7, and over here we'll have 12 plus x plus 7, which would be like 19 plus x, and then 12 minus 7 would give us 5. So we'd end up with 5 minus x, 19 plus x. That's what it would factor to right there. That's what part B would factor to. So just be on the lookout for these. You could always check your answer too. So you could expand this. You could also expand this. That expanded version should be the same. Then moving on to part C, notice again here we are dealing with a difference of squares. We got a squared minus b squared equals a minus b, a plus b, like that. And notice that this, it's already in a nice format where we could tell that the a value is this 5x minus 2, the b value is this 3x plus 4, like that, right? A squared minus b squared. And so we just have to take these expressions for a and b, plug them into this right side. So we would end up with the a value. Let's put it all in brackets just so you see clearly what we're doing here. That, and then we'll have 5x minus 2 plus 3x plus 4, like that. And then we got to simplify these brackets. So you distribute the negative in, so you'd end up with 5x minus 2 minus 3x minus 4. And over here, there's like a plus 1, so we could actually just get rid of the brackets. 5x plus 3x would give us 8x. Negative 2 plus 4 would give us positive 2, like that. Give me a sec here. Yeah, we're all good. So then you can simplify this. But we're not done here. Why are we not done? Because notice that from these two brackets, we could factor further. Notice that from this bracket, we could take out a 2. And we're left with x minus 3. Notice from this bracket, we could take out a 2. We're left with 4x plus 1, like that. And then we'll have 2 times 2, which would give us 4. Let me write the final answer over here. So we'd end up with 4, 2 times 2, x minus 3, 4x plus 1, like that. Right, so this is the final factored version. Now, another thing you could do if you want is you could expand everything, then factor. Again, I wouldn't recommend going that route. I feel like it's going to take you longer versus to just recognize you're dealing with a difference of squares, apply it to that same formula. Okay, moving on to part D. Another difference of squares, a squared minus b squared. The a value is 7x minus 3. The b value is 7x plus 3. And so applying it to that formula, a minus b, so we'll have 7x minus 3 minus 7x plus 3, right? A minus b, and then we'll have a plus b. 7x minus 3 plus 7x plus 3. Like that. So what happens here? Notice that we'd end up with 7x minus 3. Distribute this negative inside the bracket. And then because we have just a positive 1 here, positive 1, we could just get rid of the brackets. We'd end up with 7x minus 3 plus 7x plus 3. Then notice there's going to be a lot of stuff that cancels out here. This 7x minus 7x, so we'd end up with negative 6 in this bracket. And over here, this and this cancel out, we'd end up with 14x, like that. So then what we would do, 14x times negative 6, notice we could just multiply those because they're just single expressions like this. So we'd end up with what? Negative 84, like that, x. Negative 84x. So that actually ends up being the final answer, a nice simplified expression. If you were to take this, fully expand it, you would just end up with this. So there's actually, if you were to expand this, there's no further factoring you would do. But if you factor it as a difference of squares, you just end up with that single expression.